Everyone, and welcome to today's video, k closest points to origin. Given an array of points where the point's coordinates represents a point on the xy plane and integer k, you want to return the k closest points to the origin 0, 0. So we can calculate what the distance is between the 2 points by using the Euclidean distance formula, and you can return the answer in any order. Okay, so given these two examples, 1, 3, and okay, we have 1, 3, and then negative 2, 2. We have this and this, and then 1 and 3. K equals 1. We want to return negative 2 and 2 because the distance between these ones, the first one is square root of 10, and the distance between the second one is square root of 8. Okay, that makes sense. So what I'm thinking of doing is, well, what we could utilize is something called a min heap. So what we could do is, first of all, we would determine for every set of coordinates, we would figure out what the Euclidean distance is in order to figure out which one's the closest. And then given a array of the closest points and the coordinates, we can heapify it to figure out what the minimum one is. Once we're given that, we can go ahead and then iterate through grabbing the top one at each time until the amount is fulfilled in terms of like if we already have k elements, we can just stop returning elements. So first thing I'm noticing also is that you don't necessarily need to have a square root in order for you to do the comparison. If both of them have a square root, then it's official, like it doesn't really make sense to square root it. We can just keep it simpler and compare like the non-square rooted values. Yeah, and the second thing I gotta think of is the time complexity of this, which would be O of n in order to do the heapifying, and for every single element up to k, you would have to do a pop from the heap, from the min heap, and that would be a log n operation. So the final time complexity would be O of n times k log n. So if this makes sense, I'll go ahead and begin implementing it now. First thing I want to do is, given the points, you want to iterate through them. So for x, y in zip, yeah, for x, y, and I think the operation is zip for points. Actually, let me go ahead and search that up. Zip Python, make sure it's correct. Yeah, like enumerating through zip Python. Oh yeah, let's see. Yeah, it should. What it should do is iterate through the different coordinates. I just wanted to make sure. For x and y in zip of the points, we'll grab that. What we want to do is figure out the distance. So distance can be equal to the... Actually, you don't really need a zip because you'd be iterating... Sorry, it's a list within a list. So that's what actually contains the arrays. I don't know what I was thinking there. You have x, y in points. So for chord in points, you want to do, to determine the distance, you would want to figure out what the chord of 0 to the power of 2, chord 0 to the power of 2 minus or plus chord 1 to the power of 2 is. Oh, oops. Chord 1 to the power of 2 is. And then from there, what you can do is you can put that into a resulting array over here. So yeah, well, actually we'll call this min heap to make it a bit more explicit. So we can do min heap dot from here, we can do min heap dot append a new list containing the distance, the x coordinate, and then the y coordinate over here. Next thing we want to do is we want to heapify it. So heap q dot heapify min heap, and then from there on it's going to become a heap. This is an O of n operation, which you can then do heap pop operations from. Next thing you want to do is while k is greater than 0, we want to pop the largest one and put that into a resulting array. So because we want our output to be that. Yep. We have res equal to 0, and then you have res dot append heap q dot heap pop and then we pop the latest element from the min heap, and then from there what we can do is keep popping through basically every single element and moving it forward. Yeah, well, length of k is less than 0, and we want to subtract k minus equals 1, and then at the very end we can go ahead and return the res. So before we do that, you actually want to do this, and you want to just res.appends. Oh, you want to append only the coordinates. So you want to append you want to have like the smallest. We can first pop it, or actually we can have the coordinate, or like the distance, then we can have the x and the y. So actually let's call this distance, and then from here we want to append a new one with just the x and the y coordinate here. So because that's what we want, and then at the very end, after that, we can go ahead and return the res. So if we go ahead and run this, okay, oh yeah, sorry, we have chord 0, and then we have chord 1 in order to access the x and the y's. We want this again. Accepted. We go ahead and run this. That's good to go. All right. Okay. Thank you guys for watching.